Great. Thank you so much for having me, and thank you for that introduction. I'm really happy to be with
Mhm.
you to here with you today talking about how you can outgrow your laptop with R and positron. So, let's see. There we go. So I'll tell you a little bit more about me so that you can understand the perspective about with which I'm talking about this today.
Okay.
So, a very long time ago, I was in academia. I was doing physics and astronomy, and more like a medium long time ago, I was a data scientist working in organizations with their data. How can we build models? And then for about the last 5 years, I've been focusing full time on building tools for data scientists. What are tools that data scientists need? And though that sort of set of experiences has really informed what we're talking about today, which is where do we start often when we are dealing with data? What are the practices we have, the habits that we have, the kind of tools that we tend to reach for? And then what happens as our projects grow in complexity? Or if as our data grows in size, how do we move forward? I really love thinking about people's very practical applied workflows, and so I'm excited to get to talk to you about that today. What I, as mentioned in the introduction, I worked on various R and Python packages for doing things like text analysis or machine learning. But what I've been working for about what I have been working on for the last two-ish years or so is this new IDE Positron. So Positron is a new next generation data science IDE. And so that means it's like we are the same people who made our studio, and so it's like us 15 years later coming and saying, okay, what was really great about our studio and what would be a new sort of forward looking tool that would be good for people moving forward? Positron is polyglot or multilingual by design. So, whereas our studio was built specifically to use R, Positron is built to use multiple languages, including multiple languages at the same time. So if you are someone who uses Python for data science in addition to R, that's a great fit, but also can be a really good fit if you're someone who uses R together with another language. Like if you use R together with C++ for building packages. There's really great tooling for debugging and treating your C++ code as nicely as your R code. Or maybe if you're someone who uses R with JavaScript, like you build maybe complex, shiny apps. And so you can have the same kind of treatments for your files that are about JavaScript that are the same as you work with R. So it's a new data science IDE. It's built for multiple languages, and it is I think for most of you it will feel both familiar and extensible. So it's familiar because it is very inspired by our studio. So if you have used our studio, you'll see a lot of similar components, a lot of similar parts of the UI. It also will feel familiar to some of you if you have ever used VS Code, because Positron is built on top of the open source components that are used to make Visual Studio Code. So it's a fork of VS Code, much like Cursor or Windsurf or some of these other projects that you may have heard about are. So it's familiar because it's related to these other kinds of IDEs that you may have experience with, and it's also extensible because it's built on top of that code OSS infrastructure. You can use VS Code compatible extensions with it. And this means that the ability to customize or extend your IDE is really large. The opportunity there is very significant and very large. So that's a little bit about what positron is in general. For some of you, you hear some of these things and it sounds really exciting. You think, fantastic. I love to customize my IDE and make it just exactly how I want it to be. Or maybe you are someone who uses both R and another language. So you see this as really good news. But for some of you, you may hear this and think, oh no, what's happening to our studio? What's happening to our studio? So our studio is not going away. Our studio is used by millions of people every week, and we expect people to use our studio for many, many years to come for their real work. If you are very happy with our studio, then it's uncertain if it really makes sense for you to switch. And our studio is being maintained, is not being deprecated. Our studio will still be around for a very long time. If you are thinking about, I'm talking to you here about positron today, and you think, should I try positron? Should I consider switching? And the topic of my talk, outgrowing your laptop, I think is an example of something that would push you towards maybe you should try positron because there are some things that our studio is very mature and solid in, and that positron is not quite as polished yet. But there are some things that positron has that our studio doesn't have and that may never have. And so some of what I'm talking about today is in that category. New features for scaling your data science workflow that have come to positron that are not available in our studio. So let's dig into this a little bit. Let's talk about where we often start. So if you learned about R in a class like in college and university, or when you were first starting out maybe with using R, maybe very beginning of doing data analysis, your situation looked something like this, I bet. You had maybe RStudio, maybe Positron, and it was installed on your laptop or your computer. Here, when I say laptop, I just mean like a computer, like a computer that you can like look at and see. So, Positron can be installed on your laptop, and can be R can be installed on your laptop, and then there may be a CSV file right there. It's literally on your laptop. And so when you go into Positron and run R code, you can read the CSV and then you can analyze it. So I hope this is very familiar. Hopefully you think, yes, of course. Yes, the CSV is on my laptop. I use R to open it. I use maybe Positron, maybe RStudio or something to deal with R in that way. So this is a great way to work. The kind of code that you write would look something like this. You would say read CSV for this, wherever the CSV is that you want to read in, and then you can write code. If you use the tidyverse, you can write code like this, where you say like group by, summarize, arrange. So this is what your code would look like. And in Positron, it may end up looking something like this. So over on the right is the console. Right now the console is over there on the top right where I've like been typing my R code and running it. I've been making some visualizations, and so I see those there on the bottom in the plots pane. And then I've opened up my data in the Data Explorer. So when we look here at the Data Explorer, which is like view, like what you would do with view or to click on to look at it. And what we see here is like we can see all the columns, we can see all the rows. There's some nice features over in the summary panel over there where you can see the distributions of the variables here. And when we're working in this mode, that whole data set is in memory in R. it was in a file on our computer. We read it in. Now it's the whole thing is in memory in R, and I can do like group by, summarize, arrange because the whole thing is actually in R and I have access to the whole data at one time. So this is how we often start. We often start working with CSVs locally that are available locally. Maybe they're not too big, and so we can read the whole thing into our memory at one time, and we are able to do analysis in this way. So your laptop working in this way is great. And there's a reason I think that most of us teach when we learn, this is kind of like the first thing we learn how to do, right? Because your laptop is a really great place to start. And if the kind of analysis you need to do fits into this category, that's also great because that thing means your life is often a lot simpler. You don't have to worry about some of the things we're about to talk about a little more. So it's a great place to start, but for many people, it's not a place that they can stay. It's not a place that you can stay. And the two categories of problems that people tend to run into are they start to run out of memory, like maybe the data set is too big or to have in memory at one time, or maybe you can fit the data set in memory one time, but then when you try to do analysis with it, it's like, oh, I keep running out of memory. I cannot deal with this data set. So often people will run out of memory or people will run into problems with performance. Maybe they're having everything in R and trying to do some query within R. It's like, oh, it's so slow. It's like this is it's difficult for me to get the answer back in a fast, really snappy kind of time. Or maybe I go to train a model and it's like, oh, now this is really taking a long time. So your laptop is a really great place to start, but often we run into problems of these two categories, memory and performance. And at that point, if you start to run into problems with memory and performance, that's when you might want to think about another option, when you might want to think about moving to a different way of arranging your work. So in this talk today, we started there with CSV files, right? Like reading a CSV file. And we're going to talk about some options here that we step through that are different ways of working that address those problems that I just talked about. I can't do this on my laptop anymore. What am I going to do? So I did put these in order, but they're not really in an order here. They don't all solve the problem in the same way. So you wouldn't necessarily go from 1 to 2 to 3 to 4. They're like different ways of solving this problem. So I am going to talk about them in this order, but they're different ways of solving this kind of problem of like, oh, I can't work on my laptop anymore. It's not fulfilling my needs. So we already talked about what it means to just work with a local CSV file. And so next I'm going to talk about using Parquet files with the DuckDB query engine. Then I'm going to talk about working with databases. And then last, I'm going to talk about remote SSH sessions. So let's... Oh, okay. Sorry, I was hearing something on the Zoom. Let's see. Okay, so the first thing we're going to talk about is lazy evaluation with DuckDB. And so if you look at this diagram, it looks almost the same, right? Instead of having a CSV file over there, we have a Parquet file. So this is a pretty easy switch. It's a pretty easy switch. We just go from having a CSV file that is on our laptop that we can read and do things with, we switch to a Parquet file. So the kind of code you would write, it looks pretty similar. Instead of library tidyverse read CSV, now we load another package, the duckplier package, and instead of doing read CSV, we do read Parquet duckdb. And I'm going to read that Parquet file that is there. Once I have done this read parquet DB and gotten the information from the file, then you notice I can do some pretty similar, um, I can write some pretty similar code to group by and summarize. So here I'm summarizing by month and I'm computing the mean delay in these flights. This is a data set on flights here, and then I can arrange here. So the code does not change too much. The kind of code that I need to write here has not really dramatically changed. It turns out, though, what we're looking at here is actually dramatically different. So notice that it says a duck plier data frame. That is telling me that this is not the same as a data table or a tibble or a data frame in R. This thing is a different kind of thing. And what's different about it is that it has not yet been materialized, meaning it has not yet been brought into the R session, the full data set into the R session. So actually what has happened here is I have not even read that whole Parquet file into memory. So when you do read Parquet DuckDB, it is not reading the whole thing into memory in R. Instead, it's going to the Parquet file and saying, what is in you? What do you have? And then using that information to be able to do queries on it. So if I did want to actually bring it into memory in R, I would do collect right after it. And now notice that it says it's a tibble. So here, this thing right here is not in memory in R. This thing is in memory in R. So so the collect does the part that's called like materializing, where you move something from being kind of in this intermediate state where I'm doing queries, but then collect is what brings it into R so that I can then move forward, like make a plot or a visualization or train a model in R or something like that. So this is, I said we could have our Parquet file right there on our laptop, but actually this also works when the Parquet files are not on your laptop. So Parquet is a file format that is good for like analysis. Like it's built especially for the kinds of things that, the kind of work that people do when it comes to like data analysis. It's like rectangular, but with information about the columns. The columns are different than the rows, like because columns are one kind of observation, but rows are an additional observation, right? So it treats rows and columns differently. And these Parquet files, you can have them on your laptop, but they're really good for this like medium-sized data. And you can actually also keep them somewhere else. And then your R session can connect over to the S3 bucket or wherever, a computer somewhere else, a server somewhere in the cloud, your Parquet files. This is what that code looks like. So notice that instead of having a file on disk like Flights Parquet, instead now I'm going to a URL that has my Parquet files in it, and I can just do read Parquet DuckDB. But now when I do this summarize arrange, this stuff that's right here, this duck plier data frame that we have here, once again, it has not yet been materialized. It has not been brought into R. So you can read a CSV on our laptop. We can read a Parquet file on our laptop. We actually can go and we can read a Parquet file that is far away as well. And when I am writing code like this, I'm not bringing the whole file over the wire into R. I'm only just doing queries that are like previews. If you're working in Positron, it might look something like this. And there's a lot in the UI that helps you understand what you're doing. So here I've got my R file that is in a source code editor where I'm editing my file. My console is down there on the bottom left. And notice here that how it prints out, it is telling me it's a duck plier data frame. So it's telling me, yes, you don't yet have this in R. And then if you look over in the variables pane, you also see where it says question mark rows? Question mark rows by 2 columns, question mark rows by 110 columns. That's because these, like, R knows this is a data frame, but it actually doesn't yet know how many rows are in it because we have not brought the whole thing into memory. Instead, we're doing queries, lazy evaluation queries, where we don't actually even have data yet on how many rows are there. Once I were to bring it into memory, like if I were to bring it into memory, I could then use it for visualization. Like here we see, this is the delays through the year, like the average delay through the year there. So working with using DuckDB to work with Parquet files is, in my opinion, kind of the easiest, like lowest lift thing to do if you start to run into problems with, say, memory or performance actually as well, because the DuckDB query engine is blazing fast, blazing fast. So it's important to keep in mind, I'm using these two words, these two names of technologies. And so it is important to understand a bit about what these are. So DuckDB is an engine for executing queries. So it is like, think of the analogy here as being like, it's like dplyr. It's like in fact, you saw we could write dplyr code to do the DuckDB. So DuckDB is a engine for doing various kinds of queries like group by, summarize, things like that. Parquet is a file format like CSV or RDS or docx. It's like a way of storing stuff on disk. It turns out these two things work really well together. Like DuckDB and Parquet are a match made in heaven. Like they work really, really well together, which is why I'm talking about them together here today. But it's helpful to understand a bit about what are these things? How are they different from each other? Working with lazy queries can really take some getting used to. If you have, I said we almost all start with like read CSV and then working with all the memory in data, or sorry, all the data in memory. And working with lazy queries feels different. It feels different. Like if you're writing, you're like, group by summarize, and you're like executing, and it's really fast. It's really fast because you actually don't have the big giant data yet. And then sometimes you accidentally do something that materializes it, and the whole thing, everything is like chug, 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 like working really hard because it's this big data set. And usually you want to bring over data once you have like summarized it. Like usually you're not wanting to bring the whole thing into memory. You want to do some kind of like summary or analysis, and then maybe make a plot or train a model on like some summarized data. But sometimes it takes a bit of getting used to what it's like to, um, deal with data in this lazy way where you don't have access to all of it. And then if you do ever get access to all of it, it's so much that you're back to the memory problems. You saw that in the small example there, I used dplyr style code, and it is pretty amazing that you can translate between dplyr and DuckDB. Like you can say, oh yeah, I've got a DuckDB connection here. I want to use DuckDB as the backing of my R code that I'm writing. It's pretty amazing, but you need to know that not everything is supported. So I'll share these links here and a QR code that you can look at the end. But it's this is a link that takes you to an article that some documentation for what is supported and what isn't supported. So it's true that you can't do every single thing in with DuckDB that you can do with dplyr. And that is exactly because it's a query engine, it's a lazy query engine. Like it's not the same thing as having all the data available in memory in R. If you do need to read or write Parquet files yourself, like the whole file, we've been talking about doing lazy queries where we're not reading the whole file in ourselves. But if you need to read or write Parquet files, I really recommend the Nano Parquet package. It is not for doing queries or analysis. It's only for reading and writing the file. So if you ever do need to like write a whole Parquet file out or read a whole Parquet file in, it's a really great option. And then my last tip here, as we're getting used to lazy evaluation, is that once files are not on your laptop, often the hardest part is like authentication. So I showed an example of like reading from a URL, and that URL is just open to the public. So it was pretty simple. But if you, it can take a little bit of fiddly, work if your Parquet file is in an S3 bucket that you have to authenticate to with the right role in AWS and all that. Like that can be actually the hardest part of all of it. Like it can be harder than the analysis you're trying to do to figure out the auth situation. Okay, so we started with CSV files. We talked about Parquet and DuckDB, and now we're going to talk about working with databases and how you can do that and what it looks like in Positron. So the architecture, how it ends up being arranged here is what's on your laptop is Positron and R, and then R will connect to a database on a remote server. So this, you'll notice, looks pretty similar to if your Parquet files are on a say in an S3 bucket somewhere. It looks pretty similar to that. And it actually is, because R is what is in charge of the connection. R is the thing that's going to manage the connection to the remote resource here. So if you were to write code to do this, it might look something like this. So we do library tidyverse, and then we make a connection. So this is a connection object that manages how R can connect to the database. And then this database has multiple tables in it, and I can get out the flights table from it, and then I can do group by summarize and figure out, again, what's the average delay here. I want to point out a couple things here to you. Notice that, again, um, it's telling me that it's giving me information. I see the rows and the columns here, month, arrival delay, but I see this information like, oh, it's a database, it's here's where it is, all this. This is another example of lazy evaluation for queries. Once again, this is not yet in memory in R. And if I wanted to get it into R, I would do collect here. And collect is the thing that materializes the query and executes the query and then brings the result into R. So this, not in memory yet. This now an R object that is stored in memory. So it's got a fair amount of similarity to the kind of lazy evaluation that we talked about in the last section. If you were to use this in Positron, if you were to work in this way, it might look something like this. So we've got our script open where we're working. We've got the R code up there, and then I can execute and run the R code in the console down there. Notice here that it says, when I print it out, I've done group by summarize, and it is, once again, it's showing me in how it's printing what kind of object it is, whether it's an R object. In this case, it's not yet. It's just a preview. The query hasn't really been executed. It has only done like a preview of the query to show me what I will get once I execute it. Over on the other side, you see some of the UI that Positron has for dealing with database connections. So here we've got a database that has a handful of tables in it, like airlines, airports, flights. And once I'm connected to the database, like with that connection object, I can explore the database. I can scroll and click. I can click into it. I can see the different tables. I can preview. If I were to go and to click on that database icon, so I'm sorry, the table icon, the little waffle thing, it would pop up that same data explorer with a preview of my table, a preview there of my table that shows me what's in it. I have information about the columns and their types, and this is all really useful if you're like, once your data is not all on your laptop but somewhere far away, it's like a little bit harder to know what's in it and to know like how can I get access to it and how can I get into it. And so these types of UI affordances help us do that more smoothly. So if you are working with databases, I think the first thing you probably want to know is that I'm not an expert in SQL, but I think it's worth learning a little bit of SQL because even if you're not really going to use it in your day to day, like if you mostly might use dbplyr, like which is what I showed in the screenshot and the example code, like we were writing dplyr code to work with our database. So even if that's your plan that you're going to do that, I think it's worth learning a little bit about SQL, and that is because it can help you know what's going on under the hood, like help you understand what's going on under the hood. Um, the same thing applies here, that working with those lazy queries can really take some getting used to. This is especially true with big databases. Like databases are built so that they can store much more that could be stored in like a CSV file. And it is meant for reading and writing rows. You know, it's like they usually SQL is like row first, you know, like um a data structure that is made easy to like write another row, like let's add another row and let's make that fast. So if you're working with these lazy queries that need to get all of a column in and out or something, it can just as like you're writing code that's very similar, but you quickly come into contact with the fact that like, oh, actually I'm doing something pretty different here. Like instead of having the whole data set in memory and I can get any of it anytime. Actually, there is something different going on here. Also, once again, the fact that we can write dplyr and execute against a SQL database, that's amazing. That is so cool. That's amazing. But subtleties sometimes come up because it's not exactly the same thing. You are the engine. So you write group by summarize, but the engine of what's happening underneath is quite different if that thing is in memory versus if that thing is in a database somewhere. And so it's good to know, it's good to understand that some of these kind of subtle changes can come up. Um, you also, that connections pane that I showed you, you can actually use that with DuckDB as well, because DuckDB is a query engine. DuckDB can be used with SQLite, like with a SQL database. Like these are connected kind of technologies. Like they are not separate from each other, but rather things that kind of all can work together in some pretty cool ways. And again, when working with databases, often the hardest part is like getting authenticated to the database. That's literally the hardest part sometimes, like figuring out how you're going to do that and getting that set up. Often it's harder than the analysis you're trying to do, you know. So that is good to keep in mind and be ready to do that work to get authentication set up. All right, so we started talking about a CSV file. Then we talked about Parquet and DuckDB. Then we talked about databases. And now we're going to talk about remote SSH sessions. So this is another way to kind of get beyond your laptop, to work beyond your laptop. So the architecture here looks a bit like this. So what's over on your laptop is only the positron UI, literally like just the front end of the app is there. And then that within positron, a connection is managed, an SSH connection is managed to the positron backend that gets installed into the remote server. So the way it works is you say, I want to connect, and here's when I want to connect to this other server. And then when it's connecting, it actually downloads a server, a positron server onto that remote server, and then it connects to R on that server. So R is not on your laptop. The positron backend is not on your laptop. And then that server can connect to anything over there. Like the files you can have, a Parquet file or a database or a CVS file or anything can happen over there. This is a really great way to scale your data analysis if you're having problems with memory or performance, because that remote server can be a very beefy thing, can be a very strong and beefy thing there. What this looks like in positron is something like this. So if you see your R script is up here and our session is over there, this looks pretty similar. It looks pretty familiar, but the only thing that is on my laptop in this situation is the front end of the app. R here is on the server, the remote server. My files actually are on the server. And you can see I've highlighted here the pane that shows you all the ports. So these ports are all connected back and forth so that you get the good experience in positron where you can see your plots. You can access help, our help. You can run a Shiny app. Like this all is set up so all the port forwarding works so that you can interact in your with your session here. So when we think about remote SSH sessions, I think some tips to keep in mind, this is a pretty different way of working. Your terminals, your console, your files, any extensions you have installed, they are all on the remote server. They are not on your laptop anymore at all, actually. Positron has this really nice feature that controls how long your sessions run, like this is the name of the setting here. And what that means is you can connect to a remote server. You can start up maybe a very long model training. And if you have set this timeout to a high number, like 8 hours or something, 12 hours, I don't know, you can shut your laptop and that model will keep training on the remote server. Like you can reconnect to the session later, which is a pretty nice way to work. You can use all these types of remote sessions all locally with Docker for reproducibility. This does not solve any problems around memory or performance. In fact, it makes it worse, right? Like if you have a whole Docker container running everything in it, but it can be very useful if you have high reproducibility needs. And I will point you to this blog post about it. And it's no shock here. When working with remote sessions, often the hardest part is off. You need to be able to have a machine here that you can SSH to. And if you can SSH to it in a fairly straightforward way, you're going to have a fine time. But if it is a situation where it's actually a little fiddly, it has such and such set up so that you can connect to it, then that can be a bit of a challenge. All right, so if you want to try out Positron, I'll put a few links up here for you. So this QR code takes you to my slides. You can go to positron.posit.co for documentation and installers. You can find us on GitHub at posit-dev/positron. And another way of using Positron that I didn't talk about today was Positron in a whole server environment. And you can do that on Posit Workbench. So that is if I were to make a little diagram of that, there would be nothing on your laptop except a browser. And then in the browser, you connect to Positron on a server environment. So with that, I'll say thank you very much and see if we have any questions.
Okay, Julia, thank you very much for this great presentation. We now have about 5 minutes for questions. I got some of them already here. The first is, what advantages does Positron offer for package development, debugging, and testing compared to RStudio?
Yeah. So one thing that you might miss is that Positron doesn't have a build pane. Instead, it everything goes to these little terminals and you use the command palette more. So instead of having like a build pane where you go to click buttons, instead you bring up the command palette. So it's a little bit of a different like UI for how you get to it. Something that I think is really new or better is new ways of interacting with your tests. There's a whole test explorer UI that automatically discovers tests in your R package, and then you can run them. You can quickly at a glance see what tests are passing and not passing. And I find it a much more visual way of working with my tests, which is pretty nice. If you so testing all the normal kind of things you might need to do are available, but they're available up in the command palette. I think if you were going to um, say, oh, I have our packages. Should I try out Positron? I think the reasons that you might want to try it that would be say, yeah, you should try it would be like the new testing infrastructure, or especially if you build any packages that have a C code or C++ code in them. I think the experience is better in Positron than in RStudio when you have the multilingual packages.
Great, excellent. Do you think Positron is a good tool for people who are beginners in R or in coding in general?
That is a good question. I'll real talk. I don't think so today. If I were teaching a new class of like undergrads today, I would use probably RStudio today. If they're people who like R isn't their first language, like they already use some Python, then I think Positron would be great. I would say give it another year. Like if you're a teacher and you teach students, I would say give it another year, like to solidify, get a little more polished, get some more things in it. So I think for a total beginner, I would wait. I would wait. We do hope that that is true in a year from now. But I think, or maybe this fall, like, yeah, like a year from now, like next fall, I think we're targeting professors using Positron in academic teaching environments, like getting some really nice support for that, including being able to install Positron in Jupyter Hub and like other kind of formats by next fall. So I would say my honest answer today is probably not, but let's wait. Let's wait. If we're talking about absolute beginners, let's wait till about next fall.
Okay, great. And last question, Julia. Does Positron support the most common art add-ins or extensions people already use?
That's a really good question. So the extensibility story is a little different for Positron compared to RStudio. In RStudio, you could build add-ins, right? Where you wrote them in R, and then you would have them in a package, and you would distribute them that way. There a lot of those work great in Positron, but the extensibility situation is like shaped a little differently. So I would say it's like an overlapping Venn diagram. A lot of stuff works, but some of the ways, like there isn't UI to bring them up yet. We have an open issue about this to fully support add-ins. Um, the good side of this is that the extensibility for positron is much more open. Like the how you could extend RStudio was pretty constrained or limited, like what you could make it do. And in positron, because there's this whole extension ecosystem, it's actually enormous. So today RStudio add-ins, most of them that are broadly used work, but some not so much. Right today, we have some issues tracking those. In the bigger picture, Positron is much is much more is much easier to do a lot, like to extend it in a big way. Like it's much more customizable and extensible. That's a great question. Thank you all so much.
Okay, Julia, thank you for your talk. Thank you for joining us today and for the time that you have shared with us. We hope to see you again very soon. Thank you very much.
Thank you so much for having me.
Okay, bye bye. Thank you. Bueno, y muchas gracias a ustedes por haber asistido. Esperamos que haya sido de su agrado y los invitamos a seguir disfrutando de todas las actividades. Gracias.